Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 463, Island Perimeter. We're told that we're given a row by column grid representing a map where grid ij equals 1, representing where grid ij equals 1 represents land and grid ij equals 0 representing water. So 1 represents land and 0 represents water in our grid. And grid cells are connected horizontally and vertically, not diagonally. The grid is completely surrounded by water and there is exactly one island. And the island doesn't have any lakes, meaning the water inside isn't connected to the water around the island. One cell is a square with side length 1. The grid is rectangular. Width and height don't exceed 100. Determine the perimeter of the island. Okay, so we know that the island doesn't have lakes, so the water is basically isn't part of the island itself. So we don't count any water which is part of that, even inside, which isn't connected to the water outside. So we only need to count the perimeter of the actual land. Okay, so we're given some examples and we're given some constraints, and we're told there's exactly one island in grid. So there's only one island, and we need to get the perimeter of that island. So let's hop into the code. We're going to be coding this up in Java, and we actually want to create some variables, some private variables in the class itself. So we want to first start off with our rows and columns. So it's going to be an integer. They're both going to be integers, and we want to create a visited matrix. So we want to create a Boolean two-dimensional array, which is going to be our visited matrix. And this is just basically going to be a matrix which holds whether or not we've seen a cell before. And if we haven't seen a cell before, then we will carry on our code. And if we have, we're just going to ignore the perimeter for that cell. Okay, and we also want to lift up our grid. We want to lift up our grid because we want our depth first search function, depth first search method, to be able to access it. Okay, so that's our private variables done. Now let's hop into our island perimeter method and actually set those variables. So we're going to set rows equal to grid.length. Columns is going to be equal to length of the first row of the grid, and the grid is we're just going to lift our grid up, and our visited matrix, we're going to initialize it with just an empty two-dimensional array of booleans. We'll pass in the rows and columns, and now we're going to have just a bunch of false booleans in our visited matrix. And the next thing we want to do is, although we haven't written our depth first search function yet, I'm just going to get this boilerplate code set up so that we don't have to worry about that later. Row plus, so we're iterating through all the rows and columns. Copy and paste that. Change this to C is less than columns C++. Okay, and we want to say if grid RC equals 0 or equals 1, so we've found our island, then we don't need to carry on processing any more cells because we've already found our island. We can just return the result of our depth first search function. And if we don't come across any land, then we just return 0 because there is no perimeter to return. And now let's get coding up our depth first search function. So we're going to return an integer, which is going to be the perimeter, and we're going to pass in two integers, our row and our column. And we're going to let's first check if we are out of bounds. And if we are out of bounds, that means we can add 1 to our parameter. So if c is less than 0 as well, or r is greater than or equal to rows, or c is greater than or equal to cols, or if the current row and column is equal to water, then we just return 1. If we've already come across our row and column, however, and our row and column is in our visited matrix, then we aren't going to return anything because we've already visited this row and column. And then we want to set our current row and column equal to true, so that we mark that as visited as well. And now let's do the actual depth first search. So let's do the recursive bit of our depth first search function. Let's set our parameter equal to 0. And that parameter is going to store the result of all our depth first search functions which are done on the adjacent cells. So we'll do r plus 1 and c, and then I'm going to copy this 3 more times. It's going to be r minus 1, it's going to be c plus 1 and c minus 1. And once we have our parameter, we can return that parameter. Okay, so that's our code written. Let's submit our code. Hopefully we haven't made any mistakes, and we have, because we did not put a semicolon there. And of course, we aren't subscribed to Leetcode Premium, so we have to wait a bit. And our code passes all 5,833 test cases. So in terms of time complexity and space complexity, they're both going to be a big O of m times n, because obviously because of how we iterated through the grid worst case scenario, but also the fact that we are storing a visited matrix. We could actually have made this space smaller by using a set, but for this problem this is okay. So both the space and time is going to be a big O of m by n. With that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.